Let us start with the next section, students. This section contains 10 questions. Each question has 4 options, out of which one or more than one option may be correct. So let's start with question number 29. Solid AB has NaCl type ideal structure. If the distance between cation A positive present at body center and its fourth nearest neighbor is 565.6 angstrom, then we have to comment on the radius of B minus ion. We have to assume that there are no distortions in the lattice. So if we talk about the nearest neighbors present in NaCl type structure, so we have the nearest neighbor present at a distance of A by 2. We have the next nearest neighbor present at a distance of A by root 2. We have the third nearest neighbor present at a distance of root 3 into A by 2. And we have the fourth nearest neighbor present at a distance of A. Students, we have been given the value of A directly in this question. The value of A is equal to 565.6 angstroms. Now, if we talk about the NaCl type structure in which the A plus is present in the octahedral void, whereas B minus forms CCP lattice, it is mentioned to us that there are no distortions. So, radius of the cation upon radius of the anion shall be equal to 0.414, assuming the limiting case as there is no distortion in the lattice. So, we have the value of R positive equal to 0.414 times the value of R negative. We can now put this R positive, R minus in the above expression for A. So, we have twice of R positive plus R negative is equal to 565.6. And if you put the value of R positive in terms of R negative, we have 2 into 1.414 R negative equal to 565.6. So this will give us a value of equal to 2.828. R negative equal to 565.6. And on solving this expression for the value of R negative, we have R negative equal to 200 angstrom. So students, for this question, we have to select the correct answer as option C. Let us look at the next question. Question number 30. The correct statements about the substitution and the elimination reaction in alkyl halides is R. So option A, it says that strength of nucleophile is most important factor in SN1 reaction. This statement is incorrect, students. The strength of nucleophile is not a very important factor in SN1 because in SN1 reaction, the leaving group leaves on its own and the nucleophile attacks after the carbocation has been formed. So statement A is incorrect. Let us look at option B now. Increasing solvent polarity increases the rate of SN1 reaction. This is correct, students. As the solvent polarity increases, the ease of formation of the carbocation increases in the rate of SN1 reaction. So statement B is correct. If you look at the statement C now, increasing temperature increases the percentage of elimination product. This statement is also correct, students. In presence of heating, generally the elimination products are formed. If you look at the D statement now, in SN2 versus E2, increasing the solvent polarity increases the percentage of elimination product. This is incorrect, students. When the solvent polarity is increased, it means the nucleophile will be more solvated, and more solvated nucleophiles will be more stable and they will not very easily lead to elimination products. So if we talk about the correct statements, we have to mark option B and option C as the correct answer to question number 30. Let's look at the next question. Question number 31. Some organic compounds are given below. So students, we have been given those structures on the right. Select the correct statements about the above compounds from the following. So statement A, it says compounds 1 and 3 will reduce Fehling solution and will also show muta rotation. So if we talk about the compound 1, we can clearly see that the compound 1 has a hemiacetal linkage and this will be reducing in nature and will also show muta rotation. So the given statement is correct about compound 1. Let us look at compound 3 now. So if you look at compound 3, so the examiner has told us that it will be reducing in nature. So this is also correct, students. This will be reducing in nature. This bond is a hemiacetal and this will also be opened in the presence of basic medium and this will be reducing in nature. And it will also show muta rotation as generally all reducing sugars are also muta rotating. So students, if we talk about the statement A, that statement is correct. Let us look at the statement B now. Compound 4 will reduce tolerance reagent but does not show muta rotation. So if you look at the compound 4 which is given to us, this is a ketone, but it is a terminal alpha hydroxy ketone. So it will tautomerize to give us aldehyde via the enediol intermediate. So this will be reducing in nature, but this is not a carbohydrate. So it will not show muta rotation as there are no polyhydroxy components present in this structure. So the statement B is also correct, which says that it will reduce Tollens reagent, but it will not show muta rotation. So this is also correct, students. If we talk about the C statement now, compound 2 will not be reduced by Tollens reagent, but it will show muta rotation. So if you look at the compound 2 which is given to us, this will be reduced by Tollens reagent and this will show muta rotation as well, as there are hemiacetals present in the structure. So statement C is incorrect. And if you talk about statement D, the products of acid catalyzed hydrolysis of both 2 and 3 will be reducing but not muta rotating. This is also incorrect, students. The products will be reducing as well as muta rotating. So for this question, students, we have to mark the correct statements and we have to mark the correct answer as option A and option B. Let us look at the next question. Question number 32. Following graph represents the Maxwell distribution curve for an ideal gas at two temperatures T1 and T2. Which of the following options are true? So it is given to us that UMPS represents the most probable speed. So we have been given the Maxwellian distribution in which on the y-axis we have plotted 1 by n dn by du, and on the x-axis we have plotted u. If we talk about the A option now, total area under the two curves is independent of the moles of the gas. This statement is correct, students. If we talk about the area, so area will be given by integral of y into dx. So we have 1 by n dn by du, and we can have a small element on the x-axis which is given by du. So this will give us 1 by n integral of dn, and this on simplification will give us an area value equal to 1. So the total area under the two curves is independent of the moles of the gas. This statement is correct, students. If you look at the B statement now, UMPS decreases as the temperature decreases. This statement is also correct, students. UMPS, which is the most probable speed, it is given by under root of 2 RT by m naught. So as the temperature increases, the value of UMPS increases, and as temperature decreases, the value of UMPS decreases. So we're already seen that statement B is correct. If we talk about the C statement now, T1 is greater than T2 and hence higher the temperature, sharper is the curve. So this statement is incorrect, students. We had seen that as the value of temperature increases, the value of UMPS shall increase. So if we talk about U2 and U1, we can clearly see that the value of U2 is greater than U1. So the statement C has to be incorrect. And if we talk about the D statement now, the fraction of molecules having speed equal to UMPS decreases as the temperature increases. So this statement is correct, students. We can see from the graph that at temperature T2, the fraction of molecules is lesser than the fraction of molecules at temperature T1. So students, the statement D is also correct. So for this question, students, we have to mark the correct answer as option A, B and D. Let us look at the next question. Question number 33. In which of the following reaction isocyanate may be formed as an intermediate or product? So students, if we talk about the A option, we have Curtius rearrangement. So in Curtius rearrangement, we have RCOCl reacting with sodium azide NaN3. So this will lead to the formation of RCON3. So this N2 here is a good leaving group. It shall leave. The R will attack this nitrogen, and this lone pairs over nitrogen shall attack on the adjacent carbonyl carbon, leading to the formation of RNCO, which is the isocyanate. So in Curtius rearrangement, we have the formation of isocyanate. If we talk about the second statement now, which is the Hoffman rearrangement reaction, so we have RCONH2 reacting with Br2 in the presence of KOH or NaOH. So the base will extract this acidic hydrogen present on the amide, leading to the formation of RCO NH negative. This NH negative will attack the Br2 molecule, leading to the formation of RCO NHBr. Now students, there will be alpha elimination of H and Br present. So there will be formation of acyl nitrene, although it may not be isolated. So the nitrene will get rearranged to give us an isocyanate in the reaction. So students, the Hofmann degradation will also lead to the formation of an isocyanate. If we talk about the Schmidt reaction is identical to the Curtius rearrangement. So in the Schmidt reaction, we have RCOH reacting with hydrozoic acid, which is N3H, in the presence of H2SO4. So this will also lead to the formation of RCON3, as we had seen in the Curtius rearrangement, and we know that this will also lead to the formation of the isocyanate. So the C option is also correct, students. If you talk about the D reaction now, which is the carbalamine reaction. So in this case, students, a primary amine reacts with chloroform in presence of base to form isocyanide, and not the isocyanate. So this statement is incorrect, students. So among the given reactions, we can see that the reactions given in option A, B and C lead to the formation of an isocyanate as an intermediate. So students, for this question, we have to select the correct answer as option A, option B and option C. Let us look at the next question. Question number 34. Two components P and Q form an ideal solution. The mole fractions of P and Q in their ideal solutions are XP and XQ, while in the vapor phase, these components have their mole fraction as YP and YQ. Then the slope and the intercept of plot 1 by YP versus 1 by XP will be respective. So if we talk about the ideal solution which is given to us, we have the total pressure exerted equal to PP naught into XP plus PQ naught into XQ. We can also apply the Dalton's law, which says that the partial pressure exerted by P shall be equal to the total pressure into the mole fraction of P in the gaseous phase. So if we try and combine these two expressions, we're going to have PP naught into XP equal to PP naught XP plus PQ naught XQ into Y of P. So students, we can rearrange this expression. So we have 1 by YP is equal to PP naught XP plus PQ naught into 1 minus XP. So we have to deal in terms of XP, as the examiner seems to be interested in the plot of 1 by YP versus 1 by XP, upon we're going to have PP naught into XP. So if we try and rearrange this expression, so we're going to have 1 by YP is equal to PP naught minus PQ naught into XP plus PQ naught. So the denominator will be the same, which is PP naught XP. So if we try and solve this expression which is obtained, we're going to have 1 by YP is equal to PP naught minus PQ naught upon PP naught plus PQ naught by PP naught into 1 by XP. So we can now compare this expression to the equation of the straight line. So we have this on the y-axis, we have this on the x-axis. So this will be the slope and this will be the intercept. So the slope value is given by PQ naught upon PP naught and the intercept value is given by PP naught minus PQ naught upon PP naught. So if you look at the options very carefully which is given to us, we can see that we have to select the B option as the correct answer to this question. Let us look at the next question. Question number 35. Assume ideal gas behavior for all the gases considered and neglect the vibrational degree of freedom. Separate equimolar samples of Ne, O2, CO and SO2 were subjected to a two-step process as mentioned. Initially, all are at the same state of temperature and pressure. Step 1. All undergo reversible adiabatic expansion to attain the same final volume, which is double the original volume, thereby causing a decrease in their temperature. In step 2, it says after step 1, all are given appropriate amount of heat isochorically to restore the original temperature. So we have to mark the correct statement among the given statements. So if we talk about the processes which are happening in this question, so separate equimolar mixtures of these gases were subjected to reversible adiabatic expansion. So if we try and draw PV plots for these gases and for the processes mentioned to us in the question, we can plot the pressure on the y-axis and we can plot the volume on the x-axis. So we can have the initial state, which is given by V1, P1 and T1. Now they are subjected to reversible adiabatic expansion to the same final volume, which is double the initial volume. So we can have 2V1. And if we talk about the slope of the curves, so we know that dP by dV is given by minus gamma P by V for a reversible adiabatic process. And if we talk about the gamma value, gamma is given by 1 plus 2 by F. From this expression, we can see that greater the value of F, lesser will be the magnitude of the slope. So as F increases, the magnitude of slope decreases. So we can say that since SO2 has the largest F among all these species, SO2 is going to have the least slope. So SO2 will have a curve like this, followed by O2 and CO, which are both diatomic. And we can have Ne having the greatest slope among these given gases. So this is the plot obtained after the step 1 has been completed. Now it is told that they are to be restored to their initial temperature isochorically by providing them heat. So we can see that the least drop in temperature occurs for SO2 and the maximum drop in temperature occurs for Ne. So the gain in temperature shall be maximum for Ne and the gain in temperature will be minimum for SO2 after the second process has been completed. So if you look at the options which are given to us now, option A, it says due to step 1 only the decrease in temperature will be maximum for Ne. This statement is correct, students. If you talk about the B statement now, rise in temperature will be maximum for SO2 during step 2. This is incorrect, students. The rise in temperature will be the minimum for SO2 as we had seen before. So statement B is incorrect. If you look at the C statement now, there will be no change in internal energy for any of the gas after both the steps of the process are completed. This is correct, students. The gases have been restored to the initial temperature by providing them with heat isochorically. So since the temperature is same, delta U shall be 0 for all of these given gases. If you look at the D statement now, the PV graph of O2 and CO will be same. So this statement is also correct, students. Both of these have the same degree of freedom and have the same value of gamma. So the PV graph will be same for both of these gases. So statement D is also correct. So for this question, students, we have to mark the correct answer as option A, option C and option D. Let us look at the next question. Question number 36. Identify the end product in the following reaction sequence. So we have been given a ketone and a aldehyde allowed to react in presence of OH minus and heat. So this is the aldol conditions. The aldol conditions will lead to the formation of this compound. So this is the compound X which is given to us in the question. Now this is allowed to react with hydrazine in presence of glycol and OH minus. So this is the Wolff-Kishner reduction which will convert this ketone into CH2. So we're going to have the formation of Z. So Z is represented by this structure. And now when this is subjected to reductive ozonolysis, this will just cleave the bond from here and lead to the formation of respective carbonyl compounds. If you look at the compounds which are formed, there is a compound V which does not give positive tolerance test. So the ketone has to be the compound V which is formed. And if you talk about W which gives positive tolerance test, so this has to be the benzaldehyde which is formed. So this is W. And if you look at the options, we have to identify the correct structure of V and W. So we can clearly see that we have to select the B option as the correct answer to question number 36. Let us look at the next question. Question number 37. Which of the following is a mixed acid anhydride? So if we talk about CaO2, when CaO2 is allowed to react with water, it forms two acids, HClO2 and HClO3. So it is a mixed anhydride. If you talk about the BClO3, when it is allowed to react with water, it forms HClO3 and HClO4. This is also a mixed acid anhydride. If we talk about option C, Fe3O4, this is not acidic in nature. It is a basic compound. So this cannot be an option. And if we talk about the last structure which is given to us, that is NO2. So when NO2 is dissolved in water, it gives us HNO2 and HNO3. So this is also mixed acid anhydride. So for question number 37, we have to select the correct answer as option A, option B and option D. Let us look at the last question in this section. Question number 38. An aqueous solution of a non-volatile strong acid has a boiling point equal to 376 Kelvin, while another aqueous solution of a non-volatile strong monoacidic base has a boiling point of 374 Kelvin when the molality of the acid is twice that of the base. So the examiner seems to be interested in the pH of the solution when 800 ml of 0.01 molar of the acid is mixed with 200 ml of 0.075 molar of the base mentioned. So if we try and figure out the colligative property data which is given to us, we have delta TB equal to I into Kb into M. So if we talk about the acid, the basicity of the acid has not been mentioned to us. So delta TB value is equal to 3. 3 will be equal to I of the acid into Kb into M. And if we talk about the base which is given to us, there is a elevation in boiling point of 1 Kelvin. So 1 shall be equal to the I value. It is given to us that the base is monoacidic, so the I value has to be equal to 2. And if we talk about the molality, it is given that the molality of the acid is twice that of the base. So we can add a factor of 2 over here and we can have molality of the base as equal to M. So if we divide both of these expressions, we're going to have 3 equal to I by 2 into 2. So we have the I of the acid coming out to be equal to 3, which means that the acid is dibasic. It means that the acid has a general formula H2A. Now it is mentioned to us that 800 ml of 0.01 molar acid is mixed with 200 ml of 0.075 molar of the base. So we can have the value of H plus ion concentration. It shall be equal to 800 into 0.01 into 2, as the N factor of the acid shall be equal to 2, minus 200 into 0.075 into 1, as the base is monoacidic. So these are the millimoles. We have to divide these millimoles by the total ml of the solution. So when 800 ml and 200 ml are mixed together, the total volume becomes 1000 ml. So students, the H plus ion concentration shall be equal to 16 minus 15 upon 1000. So this is equal to 1 upon 1000, which gives us a value of pH equal to 3. So students, looking at the options, we can clearly see that we have to select the D option as the correct option for this question. Let us look at the next section.